Okay, so we're going to be graphing what's called inequalities on this section. Okay, so it's going to be just like graphing lines. So we're going to start all of these off the same way we would if we were just graphing a line, which means we would put it in our y equals, get 2 points, right? Because that's what you need to graph a line, is 2 points to connect. Then that's where it's going to change a little bit. Okay, let's talk about the changes that you're going to see in this section. Okay, first of all, you're either going to see a less than or a greater than sign, or less than or equal to, greater than or equal to. Okay, this right here tells you what kind of line you're going to graph. Okay, if it has this equal to bar, doesn't matter if it's less than or greater than. If it has the equal to bar, you're going to use a solid line, just like always, just like you would graphing up your y equals graphs. Now, if you don't have the equal to bar, if you're just less than or greater than, you're going to use a dashed line. So instead of solid, it is going to be dashed. Now, the way you do this in Math Lab is when you graph the line, when you plot your second point, remember doing this from 2.1, it automatically connects your points together and draws the line. The default setting is to draw a solid line. So it's going to automatically draw a solid line. In Math Lab, over in the right toolbox or wherever your toolbox is, it's going to have a button. Oh! Okay, so now what you would have to do if you wanted a dashed line instead of a solid line is in Math Lab, there is a thing over, where the U shape is and the V shape is that has a dashed line. So that, and a solid line, you can toggle back and forth between the two. So it'll have this button for you to go in and make your line dashed. Okay? If you are greater than the line, you're going to say above the line. Because what that's going to be saying is where are the y values greater than the line? The y values are going to be greater than the line above it. Okay, if you are a less than, I'm going to say below it. Because it's actually saying where are your y values less than the line, which would mean below the line. Then the last thing we're going to talk about before we start graphing these is, sometimes your y is not already going to be by itself, right? Sometimes it'll have stuff over on the same side with the y, and you're going to have to solve it for y so that you can take it to your y equals to get your points. If during that process, if you ever have to divide or multiply both sides of the inequality by a negative, then the inequality symbol flips around. So anytime during the process of getting the y by itself, if you ever have to multiply or divide, a negative number, then your inequality symbol would flip around. So if it was less than, it would turn to greater than. Okay, let's look at some of these. Like number 1. If y is greater than x minus 4. First things first, your y is already by itself, which is how we want it. So I can go straight to my y equals, just like I would be graphing a line, and put what's on the right side of that, on the other side from the y, into my y equals. So again, you're just going to y equals, clear it out. In this situation, we're just going to type in x minus. You can go ahead and graph it if you want to see what the picture is. Now, I need 2 points from this line. Remember where to find points. You want to be up on this table function. So you need to hit second table. And then just choose any of those 2 points that you want. It makes no difference. So I'll just choose 1, -3, and 2, -2. Again, it makes no difference which points you choose. So first of all, is this going to be a solid or a dashed line? This is going to be dashed, right? Because it doesn't have the equal to bar. So I know it's going to be dashed. Let's plot these 2 points. So there's a point at 1, -3. So to the right 1, down 3. There's another point at 2, -2. So to the right 2 and down 2. Now, as soon as you put that second point, Math Lab is going to connect them with a solid line. That's just what happens when you put the second point. So you have to go over here into the toolbox and switch it from solid to dashed. Okay, there'll be a little dashed line symbol that you'll see over there. So that'll switch it to a dashed line like we want it to be. Now to shade it, this is greater than, which means my y values are greater than that line above it. So what you're going to do over here in that same place as the dashed line thing, there's going to be a little paint can. That's your shader. So you just click on the paint can, and then you just click your mouse anywhere above the line. Once you click it above the line, it shades that whole region for you. Okay, so you just click on the paint can and then click above the line. It'll shade all of that region for you. Number 2. (5x minus 3y is less than or equal to 9. Oh, less than or equal to -9. So, like I said, if your y is not by itself, you're going to have to take care of that first. So, here's what I want alone. I need to get rid of the 5x, so I'm going to subtract it off of both sides. So now I have -3y is less than or equal to. These are not like terms, right? So I'm just bringing them both down separately. So I have a -5x and a -9. And then To get rid of the -3, I'm going to divide by it. And this is the other thing that we talked about before we started working problems is when you divide both sides by a negative, which is what I'm doing now. So this less than or equal to is now going to flip around to greater than or equal to, since I'm dividing by a negative. So y, turn this around, greater than or equal to, and then just do the division. This fraction just doesn't reduce, right? They are both negative, so it does turn positive. So that's going to be positive 5/3 x. And then -9 divided by -3 gives me positive 3. That's what you put in your y equals. So go to y equals and clear out your last one. So you have 5 divided by 3x plus 3. And hit enter. Now the whole point of putting it in y equals is so I don't have to find points by hand, right? I want to go to second table and then just avoid any points that have all those decimals. Pick any good points from that. So let's see, good points would be, looks like -3, -2, or 0, 3. You may pick something else, whatever. So -3, -2 would mean go to the left 3 down 2. The left 3 down 2. 0, 3. So nowhere left or right since my x is 0. My y is +3. So there's another point at 0, 3. Now, this one, again, it's going to automatically connect those points with a solid line. And this time, that's what we want, right? We want it to be solid since it has the equal to bar. And it started off as less than, but it flipped around to greater than. So again, I'm shading above the line. Number 3. X is greater than 4. So this one's going to be different, right? I can't put that in y equals because there's not a y. But the x is by itself, so there's no solving to do. What this is saying is when I draw this line, my x, think about it if that was an equal sign, has to be 4. So I need 2 points. Both of them, the x has to be 4. The y can be anything, right? There's not a y in here to solve for. So if you just have an x, you can make as many points as you want. The x just has to stay 4. Then just pick whatever you want for y. So if you did 0 and 1, this is just going to make a special kind of line. So this point, 4, 0 means to the right 4, up and down 0. This one is at 4, 1, which also means go to the right 4, but this time go up 1. Okay, if you did another one, so let's just pick another random point. The x still has to be 4, but the y has to be -3 this time. So to the right 4, down 1, 2, 3. Okay, so you'll notice what's happening here. First of all, is this solid or dashed? Dashed. It's making a vertical line. So if there is no y, Just pick 2 points with whatever it's telling you that the x is, connect them, and it's going to draw a vertical line. Now, I still have to shade because this is an equal sign. It's a greater than sign. But now I'm not going to be able to shade above or below a vertical line. What this is saying is, where are my x values? Where is x greater than 4? So where do you think, where are my x values? My x values get bigger going this way, right? They get smaller going this way. So if they are bigger than this line, they're just going to have to be on the right side of it. That's where my x values are greater than that line. Right, number 4. Y is less than or equal to -1. So just like the last one, it's going to be another special line because this time there is no x values. Okay, most lines have an x and a y in the equation of it, right? The last one didn't have any y's. This one doesn't have an x in it. So what is this saying? Think of it as just an equal sign. This is saying y equals -1, which means all the points that I plot, the y has to be -1. Doesn't matter what the x is. You just pick the x to be whatever you want. I was going to pay. The x can be whatever it wants to be. The y just has to be -1. So let's see. To the right 1 and down 1. To the right 2 and down 1. To the right 3 and down 1. So every single point, the y is telling me to go down 1. So when I do that, right 1 down 1, right 2 down 1, right 3 down 1. So all my y's are -1s. Gonna be solid this time. So that one just makes a horizontal line. So since it's horizontal, you can shade above or below it. This one is less than. Where are the y values less than that line? Where do you shade for less than? Below. Last one. I'll just short and sweet. Now this one actually has a system of 2 equations that we are going to graph in the same XY plane and see where their shadings overlap each other. That's what you're looking for. So my 2 inequalities are y equals x plus 3. I mean, not equals, y is greater than or equal to x plus 3. The other one is y is less than or equal to 2 minus x. So I'm going to graph both of these. You can actually do them at the same time. Just put this in your y1. So x plus 3. Then just go down and put the other one in the other one. 2 minus x. So I'll put the first one in y1 and the second one in y2. So when I find points, look at my table. So second table. So here's your x. Do you see how it separates the line? So y1 is going to make points on this line. And then the other one will make points on that line. So let's see, when I'm going to just go across when x is -4, on this first line, my y is -1. If I do that same x, it's -4, 6 for the second line. So you see how to pick out those points from those 2 tables? It's just like two tables in one. Let's see, and then pick another point. -3, 0, and -3, 5. So plot these 2 points first to graph this line. So -4, -1, to the left 4, down 1. -3, 0 will be to the left 3, up and down 0. So this will connect with a solid line. So there's the first line. Now plot points from the other line, and it is going to be another solid line. So -4, 6. So to the left 4, 1, 2, 3, 4, 5, 6. Oh, I should have shaded. -3, 5. To the left 3 and up 5. And it's another solid line. Okay, I should have shaded this one before I moved to the next one. So this green line, it wants me to shade above it, right? Greater than or equal to the green line. So all of this. This red line is less than. So I'm going to shade below my red line. Okay, this is actually a multiple choice problem, and all 4 options have this line and this line. The only difference between A, B, C, and D is the shading. So one of them has this part shaded, one of them has here, one of them has here, and one of them has here. What you're looking for is the overlapping shading, the section that is shaded red and green. Where are they both shaded? Where do the red and green overlap? In this area right there. Okay?